Greetings. In this video session, we are going to discuss about the protocol layering. So before going to discuss about protocol layering, what are all the topics which we have covered? We have covered introduction to computer network and what is networks and what are the important characteristics that has to be followed by networks. And also we discussed about the different types of topology available in the network and the different types of connection establishment, and also we have discussed about different types of networks. So as far as different types of network is concerned, we discussed what is LAN and what is MAN and what is WAN. And the last topic which we have discussed under the title of network types, the internetworking. So connecting multiple number of networks together is called as a internetworking. Today we are going to discuss about protocol layering. So here, before going to discuss about protocol layering, we will see what is protocol. So the protocol is nothing but it defines the rules that both sender and receiver and all the intermediate devices need to follow these rules and for making a effective communication. So whatever the components which are present in the network need to follow some rules and regulation. Either it may be a sender or it may be a receiver or all the intermediate devices. What are the devices are called intermediate devices? Either the routers, the switches, the modem. So all are considered as a intermediate devices. All these devices has to follow certain rules and regulation to make a communication in effective manner. So generally a protocol is defined as a set of rules that governs data communication. What is the meaning of governing? Governing in the sense, for making a data communication in effective manner, we have to follow some set of rules. That is nothing but protocol. So here what protocol will define? It defines what is communicated, how it is communicated and when it is communicated. These are very important. So a protocol will need to define what is communicated. That is, what is communicated means you are going to communicate a message or you are going to communicate a data and how it should be. What are the rules that has to be followed for sending a message? What is the structure of the data and how it is communicated? So what is the medium in which you are going to transfer the data from one network to another network? That is called how it is communicated. And when it is communicated. So the meaning of when it is communicated is, so this data has to be communicated through transmission medium. So at which time this information need to be communicated. So this is very important. When it is communicated is very important, because if suppose I wanted to send some data to tomorrow 10 o'clock I wanted to submit. I am asking you to submit an assignment. If you are not submitting 10 o'clock, then I already communicated that it won't be accepted. So I have created a system in such a way that those people who are submitting the assignment before 10 o'clock, it will accept, and it will say that if suppose somebody is submitting after 10 o'clock, it will be send a message that it is a late submission. Is it not? This type of facility is already available. If you see the Google Classroom, if suppose I am giving an assignment and I am giving a tentative schedule, and if in the schedule if I am fixing a time, and beyond that particular time if somebody is going to submit the assignment, so it will send a message that it is a late submission. So here the timing when the data need to be communicated is very important. So what type of data we wanted to communicate and what is the transmission medium we are going to use, that is nothing but how it is communicated, and another important thing is when it is going to be communicated. So in some system, so if we focus real-time application. All the real-time application is deadline based one. That is the reason why it is called real-time. So deadline based one means time based one. So within the stipulated deadline you wanted to make a communication. Otherwise if you are doing earlier or if you are doing late, so both will be rejected. In some cases exactly the time has to be maintained. For example, launching of satellite, right, and the flight landing system. These are the example for real-time application where we need to focus the time. So here when you talk about protocol, we already discussed it is nothing but the rules, right? So the key element which are available in the protocols are, there are three important key elements available. One is syntax and another one is semantics and third one is timing. When communication is simple, right, we may need only one simple protocol. One mechanism alone is needed to make a communication. If suppose assume that the communication is complex, then this transmission or this communication will be divided into so many number of tasks between the different layers, in which case we need protocol for each and every layer. So here that is a basic difference between having more layers in the protocol. So there is a simple communication, we need only one simple protocol to transfer the information. If the communication is complex, you are transferring a data from one network to another network. Let us assume that the source network is belong to one category and destination is different. Then what we wanted to do? Based on destination, we wanted to convert our data and then it has to be handed over. For doing a conversion, we need a protocol. So like that, if the communication is complex, then we need to use a different layers, and different layers must have a different protocol. That is called protocol layering. So the arrangement of protocol and that is a different layers will be called as a protocol layering. The protocol layering is also called as a protocol stack. In some data communication books it has been mentioned that it is a protocol stack. Here I told there are three important key elements are under protocol. The first one is syntax. Syntax in the sense it refers the structure or format of data. So we know very well that system will understand only zeros and ones. So in whatever format, for example I am giving an input in decimal format, then it has to be converted into zeros and ones. So the system or the machine will understand only in the form of zeros and ones. That is called the structure. The format in which you are going to submit the data is called as a that is syntax. Example, so we can have, I told the system will understand only the bits. So here for sending a information from one system to another system, you need to give, I already told, you need a sender address, you need a receiver address, and then you wanted to send a message. So the message will have so many number of packets. So here these are called as a syntax. The first 8-bit represent it is a sender address. The second 8-bit represent the receiver address, and then it has to be embedded. The sender and receiver address will be embedded along with message. The message is nothing but the data. So syntax is nothing but the specifying the format of the data, and along with that you need a 8-bit sender address and as well as 8-bit receiver address. That is called as a syntax. Right? By using this syntax only you can able to forward any data to the destination. The second thing is semantics. What is the meaning of semantics? It refers to the meaning of each section of bits, how a particular pattern to be interpreted. So how to, for example, you are having in previous case in a syntax, we are having a 8-bit of sender address, receiver address and the message. So how to specify the sender address, in which format it has to be specified. So we know very well it should be in bits, but how, for example, one machine is receiving this information, sender and receiver and as well as message. So how the particular pattern will be identified by that machine, that this is the sender address, this is the receiver address, and this is the actual message. So it has to be interpreted. That is the meaning of semantics, right? How a particular pattern to be interpreted, how the system or the any devices, intermediate devices, router or switches, when it receives any data, it has to identify whether it is a sender address or receiver address or it is a data. So that is called interpretation. So after interpreting the data, what type of action to be taken based on the interpretation? So here, for example, one sender is there and in between there is two routers, and then the receiver is available. So when the sender send a data, it will be received by the first router. So when it receives the information, it will identify it contains sender address, the receiver address as well as the actual message. By seeing this, it has to identify where the receiver is available. So the router will know where to send the packet, how to reach the destination. So it knows that when wanted to forward this information to the actual receiver, before that it wanted to forward to the second router. So automatically the first router will forward this information to the second router. When the second router receives this information, it knows that it has to be handed over to the destination address, which is connected to this particular router too. So that is called the action, what action to be taken based on interpretation. So the in-between router will know to whom it is going to send. That is the meaning of interpretation or action to be taken based on interpretation. The first router knows that it has to send to another router. The second router knows that it has to send to the destination. That is called interpretation. Example, the address specify the route to be taken or final destination of the message. See, for example, what is the meaning of this? Address specify the route to be taken. The first router received this information. So in this case, it knows that it has to be handed over to the second router. So here the address is very important. The location of the second router, it has to follow or it has to forward that particular message to the second router. Or when the second router receives this information, it knows that there is a destination machine which is connected to this router. So it will be handed over the information to the final destination. So that is need to be identified by the router. That is called action to be taken based on the interpretation. That is the semantics. So here semantic is nothing but pattern should be identified. After identifying the pattern, the interpretation has to be done based on the pattern, and then the action to be taken based on the interpretation. And the third one is very important. It is timing. It refers to characteristics when data to be sent and how fast they can be sent. That is very important. So here on which time the data should be sent from sender to the receiver, and in which fast, that is in which manner it has to be sent to the sender. How fast the information has to be sent from sender to the receiver. See, for example, you take if a sender produces a data at 100 MBPS. MBPS is nothing but million bits per second. So 8 by 8 bits are grouped together, we can call it as a byte. So here if a sender produces a data of 100 million bits per second and the receiver processes the data only at 1 MBPS. What is the meaning of this? Here a machine wanted to send, a computer wanted to send some information which is residing in larger network so that it can able to send 100 million bits per second in a single transmission. But at the same time, the receiver is residing in smaller network, it can able to receive only 1 million bits per second. So whether it is possible by the sender to send the entire 100 millions of bits per second in a single transmission to this receiver, whether it is possible or not? It is not possible. Why? What will happen if this sender is sending 100 million bits per second, but receiver can able to receive only 1 million bits per second. So what will happen? It will receive only 1 million bits. The remaining 99 million bits will be dropped. To overcome this problem, what the sender wanted to do is, the sender should identify what is the capability of the receiver. So what it wanted to do is, based on the receiver capability, it has to adjust the speed of the transmission. So it cannot send 100 million bits per second. So it has to reduce this data transmission. So what it has to do, as per this example, what it has to do, the sender can send first 1 million bits, then after sending the first 1 million bits, then it has to send a second MBPS, third or fourth, like that one by one it has to send, 100 times it has to send to the receiver. The vice versa is also possible, right? That means the sender is residing in smaller network and receiver is residing in larger network is also possible. But in this case, as far as this example is concerned, it will overload the receiver and data will be lost. If suppose it is sending the 1000 Mbps in a single transmission, it cannot able to receive the entire 100 million bits per second. So that is called overloading, and what will happen, the data loss will occur. What is the data loss here? 99 million bits per second. That much of data, 99 million bits will be lost during this transmission. So the sender takes more time to send the data because of less receiving capacity of the receiver. Because compared to sender capacity, the receiver capacity is less, right? So that here it will be overloaded for the receiver. To avoid data loss and overloading, we have to send, the sender has to send 1 million bits alone at particular period of time. Like that it has to send 100 times to send entire data from sender to receiver. That is the reason why the timing is very, very important. When to send the data and how fast it has to be sent. That is very, very essential. To understand the receiver capability, then only the sender can able to send. Without understanding the receiver capability, if the sender is sending the data, then automatically there may be a possibility of overload as well as data loss. So here, as far as this protocol layering is concerned, there are three important key elements. One is the syntax, which is nothing but a format. Semantic is nothing but the interpretation. And third one is timing. That is how fast and when we wanted to send the data. So here, for doing all these things, we know very well protocol is nothing but rules and regulation, and we have discussed what are all the three key important elements that has to be needed for defining a protocol. And here, why we need a standard. What is the meaning of standard? So we will be saying that certain companies are standard one. What is the meaning of standard? So their product or quality one. Is it not? So we are talking about several products. Is it not? The toothpaste or the drinks which we are taking, right? Horlicks, Boost or certain things. Is it not? So it will be having some standard. The standard in the sense, the quality of the product. When you want to define a quality or when you want to follow certain rules and regulation, then you can achieve the standard. So here, and for defining the standard, we need to follow some important criteria or important points need to be focused. And here, for making a system to be a standard one, or network to be a standard one, or protocol to be a standard one, you should follow certain criteria. What is the advantage of having to define a standard? To create and maintain an open and competitive market for equipment manufacturer. Let us assume that some company is producing some product, and that product should be a standard one or not, has to be defined. So they will be following certain rules for producing that particular product, and that for producing that particular product they are following certain rules, and that rules should be acceptable by all. Then it is called as a standard one. So here the standard is also providing the national as well as international interoperability. So India is producing one product and we are going to sell to some other country. Then if the product is standard one, then here the interoperability is very simple. What is the meaning of interoperability? Selling our product to other countries, right? Here our product will be sold to some other country and they will be using if we are providing a good quality product, and good quality product is nothing but the standard one. So before producing that product, we will be following certain rules and regulations. That rules and regulations are accepted by other countries. Then it is very important to have a standard. So if suppose here to guarantee national and international interoperability of data, the data which we are forwarding, it should be acceptable one, means then the telecommunication technology and the processes, everything has to be standard one. That means the medium, telecommunication medium should be a standard one, that is acceptable one, or the router and the devices, the interoperability devices which we are using in a network, that is also having a standard, then it will be acceptable one. And here to give a fixed quality and product to the customer. So if a product is standard one, then every people will interested to buy that product. So how we are saying that this product is good? Because more number of people is purchasing. How more number of people is purchasing that product? The product is having a good quality. If the quality is good, then automatically the standard will be there. So we know very well that this company will produce good quality product alone. That product is called as a standard one. So to allow the same product to be reused again elsewhere. So the same product will be sold to some other country or some other state or some other location, and they will be using the product again and again, so that it will provide the standards to aid the design and implementation of idea. So here already I have developed one product and that product is stamped as a standard one. That is, we know very well that that product is very good one. So I am modifying that product, I am producing a new product. Once again I am producing a new product. So what people will think that, so previously I have given a good product and they will be assuming that I will be always providing a good product. So it will help my design and implementation of idea. New ideas can be created and people will accept the new design and implementation if I have provided a standard quality product. It should not have any fault. Then people will easily accept that product. So the standards are very important. So what is the correlation between the standards and network? We will see why we need this standard and what is the correlation between the standards and this network. So here the correlation between the standard and network is the component or the devices which we are using in the network should have a standard one. Then people will be accepted all the product and the data communication. So here when you talk about standards, it is having a two category. One is called de facto and another one is called de jure. What is the difference between de facto and de jure? De facto is nothing but it will be identified from the fact, the actual fact which we are extracting. I am designing a product and that product will say something. New product I am introducing into the market and it will say something. I didn't get any standard because it is a new one. I cannot able to get the standard. That is called from the fact. So I am using that product and I found that it doesn't have any problem, so that I will be accepting that product. So here standard that have not been approved by an organized body. So what is the meaning of organized body? So organized body is nothing but the group of people. So it may be from different countries or different companies or any different designers or researchers maybe form a group. That group is called as an organized body. And here as far as de facto is concerned, the organized body doesn't give an approval for that product because it is a new product. So without using that product, how we can say that it is a standardized one. So newly come to the market and I have purchased that product, and from the fact the facility which is available from the design, I am accepting that product. So then it is coming under de facto. It have been adopted as a standard through widespread use. If more number of purchasing, if suppose I have produced one product and that product is purchased by more number of people, because without any fault only people will purchase, is it not? So if suppose more number of people is purchasing that product and they are trying to use my product, then automatically it will be coming to the standard. This is often established originally by manufacturer to define the functionality of your new product or technology. So what they will do is, they will be previously, that is nowadays directly they are releasing, previously they will be releasing a beta version. So the beta version will be spread into market and people will try to use that product. So after using that product, they may identify some fault, that fault will be rectified again and then the original version will be released. So this is called from the fact. So after using that particular product, the people or more number of people are trying to utilize the product, so that automatically it will give standard to the product. So this will be possible only for the new product or new technology. So what is the meaning of de jure? So de jure is nothing but a law, right? We have to, right? It has to be registered officially to recognize. So it will be a group of people, like organized body will be there and they will accept the product. They will test the product. We have to demonstrate in front of this organized body and they will accept and they will officially recognize our product. That is comes under the category of de jure. The first level will be this one, and after acceptance, after more people are telling that it doesn't have any problem or it is good quality one, then we can go for registering our product. So that is called de jure, that will be by means of law. So these are the two different data communication standard. Either it may be a de facto if it is a new product or technology, and after that, after usage, without any error, we are going to register our product officially as a recognized one. So that is called de facto and de jure. And here we told that protocol is nothing but a set of rules, and for this protocol we need to have a protocol layering if suppose we are using a complex mechanism. So here for understanding the protocol layering, we have taken a 3-layer protocol. So here you will be having 3 layers, layer 1, layer 2 and layer 3. And here in this example, let us assume that Maria wanted to communicate some mail to Anne, right? What she will be doing, there are 2 methods or 2 modes. One is listen mode and another one is talk mode. So whenever Maria wanted to send some information, she should be in a talk mode. Whenever Maria is going to receive some information, she should be in a listen mode. Is it not? So in a telephone conversation, one person is going to talk and another person will be listen. The receiver should be in a listen state. The same way, Maria wanted to send some mail to Anne, and so she should be in a talk mode. And that is in layer 3. In layer 2, so here she is created a message. So here that message, the readable message is called as a plain text. So she created a mail, and mail will be having some content. That content is called as a plain text. So plain text is nothing but the readable one is called as a plain text. So what will happen in layer 2, whatever the information which is available in the plain text as a message has to be encrypted. So why it has to be encrypted? Before sending this plain text message through a communication medium, it has to be that is encrypted, in the sense that we are going to follow one method to convert this readable format into unreadable one. Why we are doing this? The reason is, so when you convert this plain text into ciphertext, unreadable format is called as a ciphertext. Why we are creating this plain text to ciphertext? So when you send this ciphertext in the medium, any person, the intruder is nothing but the person who is stealing the data. So that person received this ciphertext. So when he or she is trying to open this ciphertext, she cannot or he cannot able to understand what is present in the message. For that purpose, we are going to convert the readable format message, that is plain text, into unreadable one, that is called as a ciphertext. That process has to be done by layer 2. It is going to encrypt, because Maria created a message. That message is called as a plain text. That plain text need to be converted to ciphertext by using a layer 2. By calling the encryption mechanism, we are converting this plain text into ciphertext. And the third layer, that is layer 1. The third layer is nothing but the layer 1 is having a responsibility to send a mail from this, right, Maria to Anne. So the third layer is the physical medium, which is using the transmission medium to transfer the mail from the sender Maria to the receiver, the Anne. So when the receiver Anne receive this mail, so what would be the format of this mail? It will be in the form of ciphertext. Ciphertext in the sense it is in the form of unreadable format. So if suppose this ciphertext is handed over to Anne, whether she can able to read the content? No, it is not possible. So what we wanted to do? We wanted to convert this ciphertext into plain text. For that, we are going to use a decryption mechanism. For converting plain text to ciphertext, we have to use an encryption mechanism. For converting ciphertext to plain text, we wanted to use a decryption mechanism. That means the unreadable format of message will be converted into readable one, that is called as a plain text. Then after converting this plain text, it will be handed over to Anne. So she is going to listen, or she is the receiver, and she is going to listen the content which is present in the mail. So this is a simple example to understand the 3-layer protocol. And here the direct communication is there, then we don't want any protocol here, we can simply use. But here there is a complex. What is the meaning of complex here? Here we wanted to put the person into listen or talk mode, and this is one method. The second one is we wanted to encrypt or decrypt based on listen or talk, and then we wanted to send. So for sending, one protocol is needed. For doing encryption and decryption process, one protocol is needed. And to make a system to listen or talk, for that we need a protocol. Different type of protocol is needed for each and every layer. So this is a simple example for understanding how these layers are functioning. And here, as far as this protocol layering is concerned, we have discussed what is protocol and how this protocol layer is functioning. So there should be some principle that has to be followed in protocol layering. The first principle dictates that if you want bidirectional communication, we need to make each layer so that it is able to perform two opposite tasks, one in each direction. So what is the meaning of this first principle says? For example, here two mode, one is listen mode or talk mode. So if Maria is in talk mode, then Anne should be in opposite, that is it should be in listen mode. So here the Maria is going to use encryption mechanism, the Anne going to use a decryption mechanism. Here Maria is going to send a mail, then the Anne going to receive a mail. So now you read this point. The first principle dictates that if you want bidirectional communication, yes, it is a bidirectional communication. Both person can send and listen. Is it not? Listen and talk is possible by both the person. Encryption, decryption can be done by both the person. Sending and receiving is also done by both the person. So it is called as a bidirectional. And here each layer, it has to be able to perform two opposite tasks. That is the reason why I told when one person is listening and another person can be talking. And one is doing encryption, another person has to do decryption. And one is going to send and another one is going to receive. So here in this third layer task is listen in one direction and another talk in other direction. Is it not? The second layer need to be able to encrypt and the another person has to decrypt. The first layer need to send and the first layer in the receiver side need to receive. So this is the first principle, right? So it is a bidirectional communication and it has to perform two opposite tasks, right? Each layer has to perform two opposite tasks. Then second principle is we need to follow in protocol layering that two objects under each layer at both sides should be identical. See, what is the meaning of the each layer both sides should be identical? For example, object under layer 3 at both sides should be plain text. See in this example. So layer 3, here also plain text. These are called objects. Plain text, ciphertext, mail are the objects. So as far as this plain text of layer 3 is the object. So here plain text for an other side is also same. That is, object should be identical. Here also in layer 3 it is a plain text. Here also in layer 3 it should be a plain text. In layer 2 it will be a ciphertext. Here also in layer 2 it is a ciphertext. Here it is a form of mail and here it is form of mail. So that is the second principle, right? The second principle says that, right, we need to follow in protocol layering that two objects under each layer at both sides should be identical. So in this example, the third layer both the ends should be plain text and in second layer both the end object will be in the form of ciphertext and in first layer both the end the object should be in the form of mail. So these are the two important principle that has to be followed in protocol layering. And what is the meaning of logical connection? So logical connection is the layer to layer communication is called as a logical connection. As a user, who is the user? Maria and Anne is the user and they are thinking that, right, there is a direct communication between the layers. So this is one logical connection, this is one logical connection, this is one logical connection. It is totally imaginary one. We are imagining, that is a user, that is Maria and Anne is imagining that there is a direct connection between the layers. It is not like that. Actually, the connection will be in this way. So here layer 3 has to communicate to layer 2, layer 2 has to communicate to layer 1 and from the sender side, by using a transmission medium, layer 1 has to send the information to layer 1 of the receiver side and then this layer 1 has to communicate to layer 2 and layer 2 to layer 3. But what we are thinking as the user, what we are thinking, we are having a direct communication between layer 3 to layer 3. That is the reason why it is called logical. It is not actually a physical. Physical in the sense it will be communicated like this. Actual communication will take place like this. But as a user we are thinking that it is because in a short duration everything is happening. So what we are thinking that the communication between the layers are direct one, but it is actually a imaginary one. That is the reason why it is represented as a logical. So Maria and Anne can think that there is a logical or imaginary connection at each layer through which they can send the object created from that layer. It is not like that. Logically we are thinking, imaginarily we are thinking, but actually in a physical connection it will be like this. So from this the sender will be from top down approach and receiver will be in bottom up approach. What is the meaning of top down and bottom up? Layer 3, the sender has to pass the information from top down. This is top. 3, 2, 1 is the top down approach and 1, 2, 3 is the bottom up approach. So this is the actual connection that is called as a physical connection or physical communication. So here in this protocol layering, what we have discussed? We discussed about what is protocol and why we need protocol layering, and also we discussed about the standards, why we need standards and what are the two different mechanisms are available in standards, and we also discussed what is the logical connection. So these are the things we are going to we are discussed in this protocol layering mechanism. Thank you.